The last topic about computing the volume of a solid is another technique called the method of cylindrical shell. We're going to consider another method for finding the volume of the solid. So it's going to be the solid that obtained by the region again. So you have the region under the curve y equal to fx over the interval ab, and you are rotating around the y-axis. Before, we rotated sky around the x-axis, and we used the technique called the disk method. So you see that you have the cross section perpendicular to the rotational axis. This one is the disk that we have been studying in the previous section. Uh, the next one will be if we rotate the sky around the y-axis, you see that you not be able to find the volume of the solid by using the disk, because you see that sometimes you're gonna get this curve for radius, sometimes you're gonna get this curve for radius. It's not happen in like a one curve, or sometimes the curve look like this example. So you see that this one, if you rotate this one around the y-axis, you see that you not be able to find the inside outside. Okay, so you have a washer, but you not be able to solve for inside and outside. So if you are in this situation, mathematician tells you that you can find the volume of the solid by use another method, which is called the cylindrical shell instead. The cylindrical shell is have the idea in the way that you are rotating and you obtain the solid look like this one. Okay, and you see that if you subdivide the interval AB, so you divide the interval AB into small subinterval like this one, you're gonna get many cylindrical shell. So they are called cylindrical shell. I'd like you to see my tissue paper. Okay, so you see that the tissue paper, you'll be able to obtain the volume by also summing the shell. What is the shell that I mean? The shell that I mean, let me grab my paper out. So the shell that I mean is gonna mean that you have the shell that wrap around you roll here. So you have the shell, and when you take out the shell, you're gonna get the thing that called a cylinder like this. So this one you see my cylindrical. So this one is called the cylindrical shell. And if you sum the cylindrical shell up, you'll be able to compute the volume that you are looking for. Okay, so this one you see the picture here that you're gonna have the inside shell, outside shell, outside shell like this, and you're gonna integrate. Integrate is the sum, right? So it's gonna be you're gonna sum or you're gonna integrate from A to B of the shell. So you're gonna compute the volume of each shell. So the thing that we are computing here is gonna be the volume of each shell. Okay, so it's gonna be the volume of each shell, each cylindrical shell. So the volume of each cylindrical shell turned out to be the circumference. So here is the circumference. Okay, so you have the circumference because you see that when you unfold, so you have the cylinder like this. So you see the cylinder. When you unfold it, you get the length here will be equal to the circumference of the circle that you had earlier. So you have the circumference, and the other one turned out to be the height here. Okay, so it's going to be the height here, and the height here comes from the function. So you see you have y equal to fx here, and the height here coming from the function fx, and it's going to be just circumference, which is 2 pi x. Okay, so the radius equal to x and the circumference will be just 2 pi x. And in this case, your x is the radius. Okay, so your x here is the radius. Okay, and you also have the thickness of the tissue. So for delta x here, it's just the thickness. Okay, so it's going to be just the thickness of the tissue. And this one for fx is going to be the height of your cylindrical shell. So in this case, you're going to have the formula. The volume is turned out to be the circumference multiplied with the height and multiplied with the thickness. Okay, so that will give you the volume of the cylindrical shell. And then you use the Riemann sum. It's going to be sum, okay, 2 pi xi star fxi star delta x. And this guy turned out to be integral of 2 integral from a to b of 2 pi x fx dx. Okay, so normally I gonna ask my student to memorize this guy in the way that this one is gonna be the volume is equal to integral of the shell. Okay, so it's going to be integral of the shell, and this guy is going to be 2 pi radius multiplied with the height. Okay, and you have the thickness to be your dx or dy. Okay, so the thickness turned out to be your dx or dy. So the thing that I normally memorize is going to be integrate from the over the interval that you are having your picture, and it's going to be 2 pi radius multiplied with the height, and it's going to be the thickness. Let's see one example first. So you see that for this one, I explained it earlier that you not be able to use the shell. So if you like to use the shell, it's going to be like this, and you need to find XL and XR. However, this one is kind of difficult to find XL and XR. We gonna just use the cylindrical shell. For the cylindrical shell, you're gonna just subdivide. So you're gonna write it this way for cylindrical shell. So it's gonna be, you're gonna just find a point X. Okay, so you just draw a point X. Okay, so this one is gonna be your point X. Okay, and you see that these two guys are parallel. So this one is rotational axis and this one are parallel to each other. So it's going to mean that you have parallel with the rotational axis. Parallel with rotation axis. Okay, so we have this guy parallel with rotation axis. Okay, yeah. So you see that this one will be x, and x here will be your radius in this case. And the height here turned out to be the height of the cylindrical. So it's going to be 2x squared minus x cubed. Okay. And then what? So you're going to have the shell, okay, given by 2 pi radius, like I says, multiply by height. So basically, this one, you may memorize this thing as circumference multiply with the height Okay, so it's going to be the circumference multiplied with the height. So what will be the volume of the shell that you have? So it's going to be 2 pi, the radius equal to x. Okay, so the radius equal to x, and the height will be 2x squared minus x cubed. Okay, so that 2x squared minus x cubed. So you gonna have the volume equal to integrate from 0 to 2. Okay, so this one will be your A and your B. Okay, integrate from 0 to 2 of the shell. So it's going to be dx in this case, which is the thickness. So you get integral from 0 to 2, and you're going to copy this shell down. So it's going to be 2 pi x, 2x squared minus x cubed dx. Okay, and you get, okay, integral from 0 to 2 of 2 pi, and you have 2x cubed, okay, minus uh, x to the fourth dx. So this one will be 2 pi outside, and you're gonna integrate 2x cubed. So it's gonna be 2x to the fourth over 4, subtract by x to the fifth over 5 from 0 to 2, and you would subtract x equal to 0 uh, and x equal to 2, and you subtract them. So it's going to be 2 pi, and it's going to be 2 to the fourth over 4. So 4 cancels. So it's going to be 8 minus 32 over 5. Okay, so it's going to be 8 over 5. So it would be 16 pi over 5 for final answer. Okay, so this will be just the volume of the solid by using the method of cylindrical shell. Okay, so let me do one more. We like to find the volume of the solid obtained by rotating about the y-axis the region between y equal to x and y equal to x squared. So first of all, let's graph these two functions first. So you have y equal to x. Okay, so you have y equal to x, which is 45 degrees. So this guy is y equal to x. And you have y equal to x squared. Y equal to x squared. Okay, and you have the yellow region. So this one will be just here. You see? So this one will be the region, and you are rotating this guy about the y-axis. So it's gonna be this picture. And you see that you need to use, you can use the volume by using this way. However, I'm going to use the cylindrical shell for this section. So in order to do the cylindrical shell, you're going to need to draw the height like this, and you're going to draw it parallel. Okay, I emphasize this. The height will be parallel HEIGHT, and this one parallel to rotational axis. Okay, so it's going to be parallel to the rotation axis. So the height in this case given by, so you see that it's going to be the green one subtract by the blue one. Okay, so the height is equal to x minus x squared. So you have the higher one subtract by the lower one. And for this one, it's going to be at 1, 1. Okay, and this one will be at the origin. Okay, so the shell volume of the shell will be 2 pi, okay, radius times height. Okay, so it's going to be 2 pi radius times height delta x, which is the thickness. Okay, so this one will be the thickness delta x. So it's going to be 2 pi, and the radius in this case turn out to be just x. So this one will be radius. Okay, so it's going to be x, and the height in this case will be just the green guy subtract by the blue one, x squared, and this one will be your delta x. Okay, so this one will be the volume of the shell. So the volume of the solid turn out to be integral of the whole thing. So you sum of the whole thing. So you're gonna just copy this one. Okay, so you copy this one. Okay, and then you're gonna dx. Okay, so you just change delta x to dx and you integrate. So for this one, you get 2 pi outside, integrate 0 to 1, x times x is x squared minus x cubed dx. So it's going to be 2 pi, okay? And you integrate x squared, you get x cubed over 3, x to the 4th over 4, from 0 to 1. And this guy will be just 2 pi, and you have 1/3 minus 1/4. Okay, so it's going to be pi 6 for your final answer. So you have 2 pi 12, so it's going to be pi 6. Okay, so for the next example, you are asking to use the method of cylindrical shell to set up. Okay, let me emphasize on this first. So the question asks you to only set up. Okay, so we're not gonna integrate until we get pi over 6 for final answer like before. Okay, so the question just asks you to set up. So you're gonna stop at here. So after you set up, you're gonna stop there, and then you're gonna just continue your next question. So the question asks to set up for the integral that will represent, okay, so for the integral that will represent the volume of the solid generated by rotating the region bounded by the curve y equal to root x and y equal to x cubed about the specific axis. Okay, so about y, about x, and about the line y equal to 1. Okay, so let's do A, B, and C respectively. So first of all, let's graph this guy. So you're gonna graph this y equal to root x, y equal to x cubed. So you have y, you have x. So you get y equal to root x. Okay, and you have y equal to x cubed, which is an S-shaped curve like this. So you get, I think it's going to be too big for y equal to this one. This one is better. So this one is y equal to x cubed and y equal to root x respectively. And the region that you have is given by this region, the pink guy here. Okay, so you have this region. Okay, and you have it turned out to be one like this, and this guy you gonna rotate. Okay, so you rotate this one like this, and you have, okay, so you have this height. Okay, so you rotating about the y-axis, and I draw the height parallel. Okay, so this one will be your height parallel to y-axis. Okay, so the height in this case will be equal to, you see, y equal to root x on top. So it's going to be root x subtract by x cubed. Okay, so the height is root x minus x cubed. Okay, so the shell, so the volume turned out to be intricate. The shell dx. Okay, so you're gonna integrate the shell dx from 0 to 1. And what will be your shell? So the shell will be 2 pi r multiplied with the height. Okay, so it's gonna be integral from 0 to 1 to pi. In this case is your x, right? So this one is your r. So it's gonna be your x, and you're gonna multiply with the height, which is square root x minus x cubed. Okay, and then you're gonna dx. This is how we set it up. Okay, so it's going to be just you find the volume by integrating over the interval 0 to 1, and it's going to be 2 pi x square root x minus x cubed dx, that 2 pi h. Okay, so it's going to be the shell one. Okay, so for the second one, we're gonna rotate this region about the x-axis. So let me draw the same picture again. Okay, so this one is for A. Okay, so I'm gonna do B here. So let me first, I forgot to copy. Okay, so I may have to draw this one, but it's not difficult to draw. So it's gonna be your X, your Y. Okay, and you have Y equal to root X. Okay, so Y equal to root X, and you have y equal to x cubed, y equal to x cubed, and the intersection point is at 1 1, so you have 1, you have 0, and now you are rotating about the x-axis. So when you rotating this guy about the x-axis and you would want to use the cylindrical shell, you need to draw the height. Okay, so the height will parallel with the x-axis. So for this picture, you see that I have the height here. Okay, and you have the height here, so it's gonna turn out to be x cubed. Okay, so it's gonna be this one. However, you need to solve for x. So it's gonna be x equal to the cubic root of y, and for another curve, you would have x equal to y squared. Why do I need to solve for x? Because, okay, because you're gonna need this guy, okay? So you're gonna see that this one will be the right, and this one will be the left, okay? The right is gonna be more positive than the left, okay? So it's gonna be the right subtract by the left, you're gonna get the height in this case. So the height that I gonna say here is gonna be right minus left. Okay, so it's gonna be right minus left. And for the right curve turn out to be x equal to the third root of y. Okay, so this guy will be the height. So it's going to be the third root of y. And the left curve turn out to be x equal to y squared. So you're going to minus y squared. Okay, so you have the third root of y minus y squared. So in this case, you get the volume equal to integrate from 0 to 1 again. Why do I have 0 to 1? Because you see that this one is the point 1, 1. Okay, so this point is the point 1, 1. So it's going to be y equal to 0. And here y equal to 1. Okay, y equal to 0 and y equal to 1. So I do have integral from 0 to 1. And you're going to integrate the shell and dy. And in order to compute the shell, it's going to be 2 pi h. Okay, and here you are having y. Okay, so r turn out to be y, and you're going to get 2 pi. And what is h? H will be the height, so it's going to be the cubic root of y minus y squared. Okay, so this is the volume that we're gonna write the solution. So it's going to be integral 0 to 1, and you would just copy this guy and put it here, and you have dy. Okay, so this one is your final answer for this volume. Okay, so you see, you understand. So the picture first, and then you know your right. So this one is your right, and this guy will be your left. Okay, so you have right subtract left, and this is your final answer. Okay, so that might be. For the last one is C about the line x equal to -1. Let me take the screenshot first. Okay, copies. So you have paste here. So you have C about the line x equal to -1. The same picture apply in this case. So you have this line and you have y equal to root x. Okay, so you have y equal to root x, and you have y equal to x cubed. So you have y equal to x cubed. So this one is the pink region. Okay, and you have it about the line x equal to -1. So you have x equal to -1. So this one is 1, 1. And you have y and you have x. Okay, so in this case you have x equal to -1, which is here. You have -1, and this is the line x equal to -1, and you're gonna rotate this region about this line. Okay, so you're gonna have it parallel. Okay, so you're gonna have it parallel. So you draw the height first, and the height in this case turned out to be x cubed minus square root x. Okay, so you have the height equal to x cubed minus square root x. sorry, I switched them, right? It's gonna be square root x on top. Okay, so this one square root x, and you have minus x cubed. Okay, so it's gonna be square root x minus x cubed because square root x is higher than x cubed in this case. And you see that you have 0 here and you have y here, but this guy is not the center. The center is here. Okay, so the center is at x equal to -1. So in this case, the radius turned out to be longer. So here, the radius r turned out to be kind of longer in this case. So you have r will be just uh, the height here, so it's going to be y, okay, minus 1. Okay, so let me explain this guy again. So it's kind of difficult. So you see that it's y minus 1 because you see that you have y here, right? And you're going to have -1 here. And if I ask you, what will be the distance here? It's going to be just y minus 1. Okay, so it's going to be y minus 1. So the radius will be y plus 1. Okay, so the radius will be y plus 1. Okay, and actually it's not y. It is x, it's on the x-axis. Sorry, I kind of make a mistake here. So you have x, it's not y then. So let me correct everything first. So you get x, okay? So the radius r, okay? So the radius r will be x, okay? Minus 1, okay? Not y, so this guy is x. So you get the radius equal to x plus 1. And so the volume turned out to be integrate from 0 to 1 of the shell dx, okay? And the shell in this case has the volume 2 pi rh, and it's going to be 2 pi, and the radius you just put x plus 1. Okay, so you just put x plus 1, and the height, okay, so the height will be just these two guys. So I copy, I paste here, I resize this guy a little bit, okay, and I put parentheses. So this one will be just the shell that you have, right? And so the final answer will be integral 0 to 1, and you just have 2 pi x plus 1 square root x minus x cubed dx for final answer. Okay, we're not going to integrate because the question only asks to set up. Okay, so this is the volume, and it's going to be in terms of definite integral. So you not have to integrate. Like in the previous question, this one is your final answer. You don't need to integrate this guy, and this guy is your final answer for B, and for C, the final answer is in terms of integral, in terms of x like this, and this is how we obtain the integral. Okay. Okay, so I'm gonna stop here, and this is the end of the volume. We have three types of volume. The first one is going to be the volume by using the cross section. The second one, we have the cross section turned out to be the disc or the washer, that called the technique of the disc or the washer. And you have the third kind turned out to be the volume by integrating or by summing over the cylindrical shell. So it's going to be three kinds of volume that we have. Okay, and the two kinds that we have been studying is come from the solid of revolution. Okay, so I think I'm gonna stop here and we're gonna continue the next topic about the arc length, which will be the last application of the integration next time.